Meet Harish, a software engineer here at Corsant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Corsant's flexible working culture. Explore Corsant's flexible benefits. Meet Harish, a software engineer here at Corsant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Corsant's flexible working culture. Explore Corsant's flexible benefits. Meet Harish, a software engineer here at Corsant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Corsant's flexible working culture. Explore Corsant's flexible benefits. Meet Harish, a software engineer here at Causant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Causant's flexible working culture. Explore Causant's flexible benefits. Meet Harish, a software engineer here at Causant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Causant's flexible working culture. Explore Causant's flexible benefits. Meet Harish, a software engineer here at Corsant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Corsant's flexible working culture. Explore Corsant's flexible benefits. Meet Harish, a software engineer here at Corsant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Corsant's flexible working culture. Explore Corsant's flexible benefits.
Thank you very much for your patience, waiting over 30 minutes for some people, right? So let's get started. So my name is Lyra. I'm a part of the AWS group for Colombo, and I'll give you a brief about what we are, about what we do, all the basics, and how you can get in touch with us, and also so now an AWS user group is basically a community of AWS users who come together to share knowledge, experiences, and best practices related to the use of AWS services. Now, this is what we are about, and this is what we're doing today, right? With the talk and all of us coming together, sharing ideas, an annual community day that we had last year, and we hope to have this year as well. We've been doing university outreach programs. So this is from one of our outreach programs to the University of Mondo, and these are screenshots of the community day from last year. So we got in touch with Alex and Jan, invited them for our community day. They shared their valuable insights, and maybe this time you can also join in and listen to a very interesting lineup of talks that we still haven't decided yet. So how did we start? Now, we started way back in 2019. Right? This was a great trial of Manoj Kandu. He's not here with us today. We've conducted over 36 meetups, hosted 3 community days, and we have an active user base of over 2,000 members. So that is how we start, and basically how we started. And why are we here? Right? Like I said, we are here to bring together the community and to share resources, basically share knowledge, give back to the community, right? In terms of sessions, in terms of whatever we do here is a way for us to give back to the community, right? And you guys being here actually make things even better, right? So I'll just throw this up onto the screen. So this is how you can get in touch with us. So we're on Twitter, Meetup, Instagram, YouTube, Facebook, and LinkedIn. And this time we're going to have a LinkedIn giveaway, right? So all you got to do to participate is share posts or take a picture, post it on LinkedIn, tag AWS Group Colombo and post it HQ with these hashtags, and then you will be a part of the giveaway. So post a lot more, share, as much as you can, so that you have a better chance of winning, right? So I'll tell you what the prize is at the end of the session, but for now, let's leave it a secret, right? So get posting. Did everyone capture the hashtags and everything yet? 2 screens. I'll give it a couple of seconds. All good? Awesome. So today's agenda is about building machine learning driven serverless applications on AWS. This session is conducted by none other than Lakindu. Afterwards, we'll have a session. We'll have a quiz based on the session, right? We'll have a winner for this quiz as well, right? So pay attention during the session and answer the questions. I think we have a quiz winner right over there. Last time's quiz winner is right here. So get ready, and then we will move on to our LinkedIn winner. We'll have a breakout session. So what for anyone who's new to our meetup, a breakout session is where we give a scenario and we split up into teams, and then you guys discuss together and come to the solution. We argue why this solution is better, why it's not good, what are the drawbacks, what are the advantages of using this type of method, approach, and then basically a knowledge sharing session, right? And then we'll have our session feedback, right? All right. So without further ado, that's it from my side. So without further ado, let's welcome Lakindu to do today's session, right?
Thank you.
Okay.
All right, hi guys. I hope you all can hear me.
Okay.
Yeah. So we'll just stick to this. So yeah. So my name is Lakindu, and today we are going to be talking about something very interesting. So it's about building machine learning driven applications through serverless on AWS. So it's not. So if I were to say how complex this topic is, I would say that it's a bit of an intermediate level topic. So it's not going to be full beginner friendly, and it's not going to be a very techy talk as well. So it's going to be fun. It's going to be fun. So ask questions. Make sure you interrupt me along the way. So that's how we're going to make it fun. And right off the start, I'm just going to share a QR code right here. So y'all can scan that. Y'all can follow along with me for the presentation. So that's going to point you to the deck. So y'all can just scroll down with me while we just go along this journey. So yeah. So before we start, I just want to get kind of an overview here. So could I know how many of you are familiar with machine learning? Just a quick raise of hands. Those are familiar with it. Like you have built models, you have deployed, and you are currently running many workloads, or you have just like have experience. Okay, awesome. So we have quite a few of you. And who has experience with serverless? Who has ever heard of the term? Okay, so we have 1, 2, 3. Okay. Okay, wow. So movement is really happening. Okay. Advocate. Okay. Awesome. So then we'll just quickly, I'll just browse through the content, and yeah, we'll have fun demo at the end as well. So a bit about me. So I'm a senior software engineer at Enlia, and I'm also an AWS community builder. So what that means is I love contributing to open source and anything open source related, anything I get my hands on, I try to contribute to it. And I do a lot of blogging. I'm a blogger, so I have a Medium, and I do a lot of tech content writing as well. So that's pretty much about me. So what made me really start this conversation is, what does it mean to be building with machine learning in 2024, right? So, forgot to mention. So, any slide that you see a QR on, it's going to point you to a resource, right? So, all of those resources are where I got my content for the deck from. So, this is coincidentally an article I wrote, which you'll be pointed to. So, it might be biased because it's my own words, but yeah. So, for me, when you say, what does it mean to be building with machine learning? So before we talk about that, let's take a look at like 10 years ago, right? How we started with machine learning. You had to go out and understand your domain, right? That's obvious. And then you had to collect data. And then you had to experiment with a lot of models. You have your neural networks, you have your basic classification and regression algorithms. So you just plug all of those algorithms and you see which one works for you, right? So even if it's a classification problem where you're just trying to figure out, you give an image and you just say, okay, is this a cat or a dog? Is this a bench? You just ask that from the model, and it just gives you an answer, right? So think about how long it takes to build something like that. Usually it takes months of proper data collection, data refinement, training, testing, validation, and you might do hyperparameter tuning. So there's a lot of stuff that goes on before you actually get to consume your model, right? So can anyone who has done machine learning agree with me on that fact that it's like insanely time consuming? Okay, so we do understand that, right? So then you have your shift, right? You had companies, you had third party open source contributors coming into the picture, right? You had all of these people coming in and they started building these models off of data that they've collected over years of research and development. Particularly to any different use case, they try to collect as much data as possible, and they try to train this model, and they try to give you a service that you can consume. Do we all agree with that as well, right? So who here has used any one of these three services, right? OpenAI, Hugging Face, or AWS. Anyone has ever heard of these three words? Yeah, all of y'all have done, right? So this is where the shift really starts, right? So You first have OpenAI where they came in and they started with their large language model, right? So they started with GPT, they started with Dolly, and they had their own code analysis or model as well, which was really good at generating code, right? So all of this is used to make the life of a developer much simpler. That's the whole point of it, right? They don't want you to keep reinventing the wheel. So in software engineering, you have an acronym called as KISS, right? So you want to keep it simple, stupid, right? So that's essentially what's happening. They want you to make things simple. So OpenAI has their own set of models. Hugging Face is an open source vendor where they have their diffusion-based models. So these are all towards the generative AI sort of spectrum, which is a talk for another day. So the one that we are talking about is AWS. You have these cloud vendors coming in and giving you their solutions. They have done their own R&D, and they are ready to give you API-based solutions which you can directly consume on your applications. So this is where the whole shift concludes by saying it's better to use pre-trained models where you just inference off of it. So for those who are not familiar with inferencing is essentially this fancy ML term where you just give real data and get an output from the trained model, right? So that's as simple as that. You just give the API model its data, and it just gives you an output. It goes through its entire evaluation process, and it determines the output for you. So that's inference. So that's the whole talk, right? I'm not going to be walking you through on how you build a custom model, because I believe that all of us can figure that out through a YouTube video, right? So this is the part where it gets really interesting. Like, how do you build off of machine learning solutions that are on AWS? So some of the very first introductions was computer vision. So computer vision is essentially a capability of a computer to analyze real-world objects and give meaning to it. That's essentially vision, right? And for that, AWS came up with a lot of solutions, but I'm going to be focusing on recognition. It's pretty cool, right? So, but not the point of the talk again, just to show you that it exists. So what recognition does is, it has its capability of analyzing images. It has been trained on over millions and millions of images of people, of objects, of atmospheres, of celebrities, you name it, they have done their training on that. And what this model or this service can ultimately do is, it will expose an API where you can analyze these images, right? So for example, in this is right from the AWS documentation or right from the AWS service page, just give it something and it gives you this whole list of analysis it has done where it says, okay, this woman, okay, first of all, it says it looks like a face and it's 99.9% sure that it is a face. And it's also capable of deducing the age range, right? So that's something you can use when you're trying to profile someone, right? So off the top of my head, a very good use case would be for crime reporting, right? You have your CCTV footage, you have your security cameras, and they are fed through a real stream onto recognition. So you take the you take the picture or video and you split it down into image frames of images, and you pass it to recognition. What recognition will do is it will analyze these images and it will give you a description. So the traditional way, how you profile someone. So have you all watched crime shows where they ask you to describe what the person looked like? So they'll tell you they looked at this age, they had brown hair. So Brooklyn Nine-Nine has really good scenes of that. So what they do is they describe that, and most of the time the sketch is wrong, right? Most of the time. So there's this really funny part, if you have watched Mr. Bates Holiday, where he describes a person has a banana tattoo on his face. So that kind of problems are all gone with recognition, right? So it's able to give you a very wide view of an output. And that's not the only thing it can do. So let me just, So let me just show you. So I'm not gonna be going on the slides. So just have this ready. So what we'll do is we'll try the demo, right? So this is directly available. So what happens here is, okay, let's try reloading it. Okay, so is it working? Yeah. So if we do this, so this is, it would work better if I had a larger monitor, but let's try to get through it. So here, if I hover over it, recognition can literally tell me what object it sees. So Mission, what was it? Mission Impossible, where they had that whole eye thing, or even Fast and Furious had that whole eye. So that's like an eye right there for you, right? The God's eye. We call it the God's eye there. So it's able to recognize a wheel. It's able to recognize a car. So it won't tell you what type of car it is, but it's just good at object recognition, right? And another one is facial analysis. So that's what I just showed you. So it's able to tell you all of these properties. So this woman appears to be happy. A. Okay. So it tells us that. Does not have a mustache. Okay. It's 98% sure that it doesn't have a mustache. Okay. Not only that. Wait, it gets cooler. It gets cooler. Okay. We've always wanted to figure out what kind of celebrity this is, right? It can do that. So you just give it a celebrity and it's able to understand that this is Jeff Bezos. So it's almost 100% confident that it's Jeff Bezos. So that's the kind of power that these services bring. So imagine if you had to build this from scratch, how much of a pain would it be? You'd have to collect all of this data, you have to map it, say which image is which person, right? You have to do your transformations, everything. And it's also very good at color segmentation. So if I look at this, okay, it's not that. So there's another cool service where it's able to understand colors in an image, right? So if you are an artist, if you want to draw something, if you're a graphic designer, you don't know what color it is. So rather than using a color picker, you decide to use this, right? So you just give it the image and it's able to say what color and what spectrum it's in. So it gives you all the properties of brightness, sharpness, saturation, contrast, and everything, right? So that's the power that recognition brings onto the industry, right? So that's one of the services, but that's not the whole point of this talk, right? The whole point of this talk is data extraction. Now, who here? So when we started this talk, before you came in, right? You had your name tag. You got a name tag, right? You wrote your name down and you pasted it. So none of you all are pasting it, but you wrote it down somewhere, right? Okay. So we have that name tag here. So what data extraction will do is, some way or another, one way or another, you will need to collect this data and analyze, right? So let's say we had our RSVP list, but we had a few walk-ins. So we want to know who these walk-ins are. But we can't read your handwriting because it's 2023 and no one uses pens anymore. So what we're going to do is we're going to use data extraction or text extract in particular, and we are going to pull information from it. So it has been trained on several millions and millions of data. It has been trained on bank documents. It has been trained on vaccine cards, letters, forms, tables. And it's able to understand human language or natural language. That's what you call it, natural language processing. So that's essentially what this is about. So again, we have a small example here. So you can see that you gave it this entire payslip, right? And what it's doing is, underneath, it's taking the image and it does what you call as an OCR mechanism. So OCR is an optical character recognition, right? So it's able to read text. And when it reads this text, it's able to output a bunch of raw text. So it strips all of these fancy dividers and colors and everything, and it gives you a bunch of raw text where you can do your processing on. But that's not what we really want, right? In 2023, you don't want to extract data first and get it onto a database. And you don't want to, again, go through your database and understand what's there. You directly want an output. That's how demanding the industry is. You have to move with the pace, right? So this is the shift on our talk. So we are going to talk about this thing called as extract queries. So a query is literally anything that you ask. So I might ask you, how was the weather today? That's a query that I might ask you. And you might give me a response on what the weather was. So what extract can do is, you ask it a question and it's able to understand, based on the data it's been trained on, where it might see the mapping, potential mapping, right? So for example, this person, AWS had in the demo asking what is the YTD gross pay. So it's able to pinpoint that exact location and say that's the gross pay that this person is having. So likewise, you can do a lot more stuff. So traditionally, when you are building something like this, so for those who have not worked with OCRs, I'll tell you the process, right? So you have a device, you scan it, and after you scan it, you get a bunch of raw text. And then you write code on top of this text. You say what's supposed to happen. You're supposed to give these synonym lists, right? So what if I say instead of gross pay, what if I say total pay? Then this model is all gone, right? Because there's no such thing as gross pay. You might be wondering now, gross pay is mapped here, so obviously it might have picked this, but that's not the case. It's been trained on several synonym lists and templates, so it knows exactly what's happening and it knows the synonyms that you passed through it. So query is another model that's trained on top of extract, right? So again, I'm not gonna talk too much. So again, I'll jump into the demo, right? So let's go back to Chrome. So this is TextRack, right? So I'm just gonna try TextRack, and then I'm just gonna show you how it works. This is really interesting. So next, what we're gonna do is, so now this is the traditional OCR output, right? Doesn't make sense for us. Ours, do you want to do what something is? So it knows it picked it from here, right? So we really don't care about this raw text. Then you have a layout. It's able to understand what are the different types of layouts available in a document. Important, right? So if you want to analyze part of a document and get rid of the rest, you can just put out an alias type of thing behind the scenes. I'll show you how it works. So you can just say that and it will pick out certain segments of your document. That's another thing. But the most interesting part is this right here, right? So let's say I have federal income tax. So if I click on that, you will see that. I don't know if you can see, but yeah, you see that it has picked this one out when I say that. So that's the part. But then again, you might be wondering, it's written there, right? So let's put in our own query now. So I'm just gonna type and say, okay, it's there for me. What's the company name? Now, if you look at this document, can you tell me any particular label which says it's the company name here? So when you look at it, you know that this is the company name, right? Right there, that's the company name. But extract doesn't know that. All we are asking is, what's the company name? So based on our theory, it should be able to give us the response, giving us the company name. So see, it directly knew what's the full name. So it missed out on the part where it is any, but then it started off with this part says company. But yeah, that's the power of it. So you can run your own stuff as well, right? It's not just, you don't have a restriction here. So if you have employee name, so there's another one that says employee name, so you can run that. So you can come up with your own queries. So it's pretty cool what the power that it offers, right? So now, here you don't have anything which says it's the employee's name. You just have this John Stiles and the address, right? So based on its data set that it's been trained on, it's able to tell you where it is. So that's the whole point of our talk today. So we are going to be looking at how you can build applications around this TextRack queries, right? So now, are you following along with me? Do you like get the whole power of this TextRack query? Like, do you see where it can be used? So can I get a raise of hands if you all feel like you all still don't see where it's gonna be used in your life? Not in your life, but in your use case. Do you see a use case for it? Do you see a use case? Let's go with that question. Yeah, do you see a use case for it? Anyone who sees a use case? Help me out, please. Okay, so we have a few use cases, right? Yeah. So again, you don't need to write any post-processing, and there's no payment for this upfront. You pay for the document that you scan. You don't pay for these queries. So I'll go to the pricing page next. So the pricing is this. Okay, I just want to show you the type of documents. So I actually did this. I analyzed this page and I just asked you to give it some. So all of these three, so it's able to understand who was the sender and who was the recipient, right? So you can't ask it to summarize because it's not a language model. It's just data extraction and analysis, right? So you can't ask it to summarize or create new content, but instead you can take out meaningful data from it. So here's the pricing. So note that, so there's one thing that I didn't show you, which is signatures. TextRack can identify human signature, and you can give it an option to directly export it onto a bucket if it identifies the signature. So those are some of the other use cases for it. And first million pages in a month, you get $15 per query. So if you divide that by 1, it's less than a cent for a single query you pay, right? So at large scales, it's very cost efficient, right? So that's the whole point where I'm trying to get it. So if you employ a person to do this job, right? How much of a salary would you need to pay to analyze millions of documents or thousands of documents? So millions of documents per month is not possible for one person. Let's say 1,000. So a few hundred, couple hundred ranges, right? Maybe close to 500, 600 documents per month, I'm assuming. You still have to pay hefty stuff, right? You have a lot of upfront commitment, is what I'm saying here. But here you don't have any upfront commitment. You don't need to pay to provision a extract instance. It scales up and down. It's able to handle the workload for you. But there are a few caveats here. There are a few rate limits which we'll be talking about when we design the solution. But yeah, ultimately, this is what you're left with. And the free tier, you get all of these three under the free tier for the first 1,000 pages within the first 3 months of your free tier in AWS. So again, another bonus, so you don't have to pay if you're in your free tier and you are within these limits. And signatures, of course, if you are combining all of this without just extracting signatures, it's free for you again. So yeah, very cost efficient solution for modern document analysis is what we're saying here. So how does serverless play to this, right? So I want to make it fun, so I don't know if anyone would. So could anyone tell me how they see serverless fit into this picture? Anyone would like to take a shot? Like there's no right or wrong answer, because when you build solutions, it's about how you justify your reason for it. So does anyone want to give it a shot and say, why would you use serverless in this picture? I'll let like another 10 seconds. Anyone? Anyone who will raise their hands and say they're working with serverless? So, okay. How would you say that serverless plays a role in building applications on top of this, right? So you could either host it on an EC2 instance up and running for your workload, and you would route extract onto that, right? So your application would run on EC2 and you would consume it through extract. So my question is about what if we build a solution, an application around serverless, which consumes this service, right? Based on the pricing model I discussed, based on the limits that I discussed, how would you say, how would we be able to justify serverless being a good option to build a solution around this? Yeah, so likewise, so exactly the direction I was going for. You don't necessarily have to work on other infrastructure because this service is already good to go. So that's one other benefit of that. And not only that, you want your system to scale to reach its full potential, right? So EC2 instances or any server-based deployments, it's your resource can scale as well as you define the configuration. So if you have auto scaling set up to about 10, 15 instances, that's how good it will scale to fulfill those requests in a load balancer, right? But Lambda and TextRack. So TextRack can scale again on demand basis based on your requirements. So if we put auto scaling group on top of this with a lot of EC2s, you are not directly leveraging this, right? And who's going to be analyzing documents 24/7, right? Are you going to be analyzing documents every single day, right? So if it's, okay, again, two parts here. So if you are going to be analyzing it every single day, 365 days, and you're going to have very little idle time, serverless is going to be a bad option for you. But the whole talk about this is we are going to assume that based on the requirements that I came up with, we are going to analyze it twice or thrice a month. So we get employee payroll records, and we just want to see, okay, we made this payroll to this third party vendor. We want to get some data out of it. We're going to use it maybe once or twice a month, but when we do use it, we are going to be using it to the fullest potential. So why would you want to pay for the remaining 28 or 29 days of the month? So that's the whole point that I want to say. Because when you use an EC2 or any server-based deployment, right, you're going to pay for the hourly rate times 24, that's going to give you a daily rate. You multiply that by 7, that's going to give you your weekly rate times 4. Right? That's for your month. So why would you pay for that for just 2-3 days of usage, right? So that's another point that I wanted to talk about. And scaling, of course. Lambda, again, serverless ability to scale on an on-demand basis. You want it to scale, it will happen. And the next one, highly available, right? Serverless, again, automatically deploys it in multiple availability zones. So for those of you who don't know what an availability zone is, it's this data center, these number of X number of data centers that are present in an AWS region. So when you deploy something, AWS goes and replicates across these regions. Some cases you can deploy globally. So if in case one availability zone goes down, Lambda service will automatically tail over onto its next availability zone and continue serving it. So again, you don't have to worry about building highly resilient architectures. So serverless on its own is pre-baked with high resiliency, right? So that's another benefit, right? So, okay, jump the slide. I jumped my there. So I wanted to talk about serverless, but then I think we already covered it. So serverless, right? So I would define it. So I have to take one gear back and say that serverless is literally any service where you don't, so again, no right or wrong definition, but from my experience using it every single day, I would say that it's a service or any service offered by a cloud vendor where you don't have to manage servers. It offers a pay-per-use model, scales when you need it to, and it's highly available. Okay, but now you might say, aren't all cloud services pay per use, right? You pay for the EC2, but what do you use? But you pay for idle, right? So with serverless, you never pay for idle. If you are not using the service, it's not gonna be there. It's gonna die down. And when you want it to process a request, it will initiate a container and it will serve your request. That's how Lambda works. So I would say you never pay for idle because you only pay for the number of milliseconds or couple of seconds that it does execute. So that's how I would say serverless plays a big part in this. And the other one is when you pair these two together, all of these ML-driven services that we're talking about, recognition, extract, you have comprehend, all of those natural language-based or computer vision services, they are driven by APIs. They directly process based on events. So an event is like, for those who are not comfortable with event-driven, event-driven is basically what do you do when something else happens. That's the simplest definition it can get, right? So if it's freezing in here, what are you gonna do? If it's freezing, you're gonna realize, okay, it's really cold in here. I have to go and turn down the AC, right? Or you might ask someone else to go turn down the AC. So event is emitted and it is consumed by you and you do whatever you want. There can be multiple people, right? So 2 people can feel cold, 3 people can feel cold. So do you get where I'm going with this? With serverless, you have the same thing. When something happens, you can process it in different ways. So that's exactly what's happening here. So when we take a look at how event-driven plays a role in our solution, first of all, user upload the document. That's what happens when you start to process something, right? User will go, you will go and take a pay stub or any document and you will upload it onto the system. Then we want to say, hey, someone just uploaded something. What should I do next? Okay, I'll process that and I'll give it to TextRack, right? I'll give it to TextRack and say, hey, TextRack, there's a document ready for you. Why don't you process it right now? And then TextRack will be like, something just happened and I just analyzed the document. What should I do next? So do you see that your system has no cupboard, right? So you don't build everything in one giant sequential order. You let it go on its own direction and every entity has a single role to play. You don't have one thing saying, okay, upload this, do that, nothing like that. These are all events where they independently act on it, right? So one person will say, okay, document analysis is complete. Okay, I'll send an email to the user saying, your document is ready. On the other end, I'll be like, okay, I need to go and take that document that's analyzed, right? So what do you do when you send a document to print? Classic example, you press Control P, you print it, the printer will tell you notification saying that it's done. That's essentially this event. Then what you do, you get up, you walk to the printer, you take it and come back and store it. That's what we are doing here. We take the event, we say TextRack, give me the document that you just analyzed. I want to store it for future references. Essentially, that's it. And finally, you have your HTTP requests, your API. They also can be driven by event. You don't have to couple an API to its business logic. You can just say, hey, somebody just gave me this user ID, somebody just with this user ID, they want to take this payload, this path parameter, they gave me this, I'm giving it to you, but you do what you want, you give me the response, I'll just be an intermediary and push it back to the client. Simple as that. So that's how event-driven plays a part in this, right? So it's gonna be a bit boring for like 10 minutes-ish, but try to bear with me, right? This is really interesting. So what are the services that we're gonna be using? Extract S3. S3, those who don't know what it is, simple storage service, highly scalable, highly resilient, and highly available storage is in the cloud. If I'm not mistaken, it has, I think, about 5 nines in it. It's availability scale. So it's very durable, right? Then you have Lambda. Lambda compute service driven by events has the capacity to scale on an infinite basis if you design it correctly, without you doing anything. You don't even have to define and say, okay, I want to scale at this time. It knows it needs to scale, right? And it does that. We're going to use a queue here. That's very interesting. We're going to use simple queuing service. Serverless queue, right? Does anyone know what a queue is? Like anyone like with data structures knowledge, right? So queue is first in, first out basis. You process data, right? So is it? Okay. So that's what we use the queue for. I'll tell you why in a bit when we start designing it. And then notifications, simple notification service. This is essentially where I talked about after the document analysis is complete, what I'm going to do. DynamoDB, I want to store my data in it, so I love NoSQL databases, so I went with this. But you are also capable of using any serverless database. You have Aurora Serverless, which is another good SQL-based solution if you are into SQL Serverless. So yeah, and Amplify and Cognito. Amplify, I've used it to manage the front-end application, and Cognito, I've used it. So I won't be making you all sign up into my system, so I didn't want to do that. But I wanted to create a secure entry to my S3 bucket because I want to directly upload from my front-end application to the S3 bucket. So I use Cognito to create an anonymous identity, which is going to last for like 1-2 minutes-ish. And that's going to be used as a token to insert objects onto the bucket through Amplify, right? As simple as that. So the first phase is client design, right? What's the customer going to use? So from the customer's perspective, we have AWS Amplify. Those who don't know what AWS Amplify is, it's essentially, I would say it's partially an ISC-based tool, and it lets you communicate with AWS services directly through your client. You don't have to have an intermediary. So what I've done is I've completely dropped the backend communication through my API gateway, and I've just had an Amplify integration to S3, and from there, so the second step would be through the Cognito user pool, which is where I'm going to be storing my identities, and from there I'm going to get an anonymous authentication, and I'm going to push it on to S3. And when I push it on to S3 is where the fun stuff happens behind the scenes, right? So when it does get uploaded onto S3, I want to start my document analysis. So when what I do is I have a Lambda function that gets this image that's being uploaded, right? So it takes this image and it begins this thing asynchronously. So it gives it to texttrack asynchronously. So what asynchronous means is it doesn't wait until it finishes its analysis. It fires and forgets that it ever happened, right? So why I do this is, if I start to do this synchronously, this Lambda function might have a bottleneck because it's waiting until it serves. So if you give like a 15-20 page PDF document, it will keep this open until it finishes it, if I do it synchronously. So that's high cost also, right? Because I have to pay for that time the Lambda function is invoked, and you also have your Lambda function timeouts. So generally, if your Lambda function is running for more than, I don't know, 10 seconds even, I would say that it's not a good use case of it because you are paying for a lot if you are managing at high scales, right? And then what you do is you give it to texttrack, and through texttrack, it analyzes the document. So I don't do anything there. I just tell texttrack, hey, I gave you this document, I want you to analyze it, and these are the queries that I want to answer. So that's what I'm doing here. And after texttrack will analyze it, what I'm going to do is, I'm going to say, texttrack, once you analyze it, just notify somebody. So that notification process is done through SMS. because TextRack automatically supports integrations to notification services where you can emit events and say, hey, I have done processing, this is the doc that I did. And then I directly have a subscription to a queue. Now you might wonder, why do I do that and not another Lambda function? Now the tricky part here is TextRack by default comes with the 10 requests per second limitation, right? So that is again incrementable if you send an email to AWS and specify your use case. But if it is, that takes maybe 1 week's time. So what I have done here is I have added a queue for my flow control mechanisms, and I have added a small delay here. So and says that to fit the rate that TextRack is pushing documents, you take the messages onto the Lambda. So you poll it at a delay, right? So polling is rather than SQS pushing it on, the Lambda function will go and fetch items from the queue, delay. And what that does is, because it's delayed, I will again take TextRack, because after the analysis is complete, the payload is sometimes way too big to pass it directly through a subscription. So what it does is, it caches its response for 4 days on the service itself, and then it sends a job ID through the flow. So that's how TextRack works. And then the consumer will have to talk to TextRack and get the job done, job information by querying TextRack again. So that's the whole flow. So if you have a case where you have this at a very large scale, that's happening, so this entire flow is happening at a large scale, then you would have a delay or a rate limit problem here, right, with rates. So that is the whole purpose of the queue. And finally, once TextRack gets the documents, what I'm going to do is, I'm going to store it inside my DynamoDB table. So that's essentially it for the entire backend for the fun part, like the text analysis part. And then I've also added an API gateway, right? So API gateway, if you're not familiar with it, it acts as a forward-facing service, which actually talks to your internal AWS services, simply put, right? So what I've done is, I've built a REST API, which lets you fetch the data that you have processed. So initially, when you submit, so what I've done is I've created a small synchronous flow in the code, where once you send an object for processing, I create another API request and say, these are the queries that are supposed to run, right? So that is again done in the forward facing, which I'll show you in a bit. And then I have the job ID, and I use it to periodically poll the request. So I've done that so that the client will know that the job is still ongoing through TextRack. So rather than the client also forgetting what's happening, they are also understanding that, okay, my document is being extracted. I should show loading sign until then. So that's what happens there. And then after it finishes the analysis, I have another endpoint where it fetches analyzed documents by an ID. So that is pretty much it, right? So that's the whole architecture, and that's the whole app that I built. So you can try it out right now. So just scan that QR right there, right? So just scan that, and you all will be directed immediately onto the code for the application, or you can just visit this URL. So it's texttrack.luckyhellavasam.com, or you can just go ahead and open the app on the QR and it will take you. So how does that work in real life, right? So let's see. So I've had it opened up here. So when you open it, it's going to process all the documents. I've set up a CloudFront distribution. That is why it's so fast at loading here. So this is something that you're not supposed to do, because this is something that TextRack will not understand. It's meant to analyze documents, not it's not meant to force stuff like this. So it doesn't have a response to it, right? So that's something that you should not input onto it. But yeah, so let's okay, I'll add a file quickly. So I'll go to my desktop and I'll maybe pick this simple receipt, right? So do you all have any queries that you all want to ask TextRack? Anything we could ask together? Do you all have anything that you all want to know from this document? Anything? Visually anything? Anything would be fine, you know? But what's the recipient? Okay, so let's type that. that's one. Anything else? Sorry? Did anyone say something? Anyone say something? No, okay. Anything else? Okay, I'll do my own one then. Okay. So, one thing that I might ask is, maybe who is the shipper? Maybe I'll ask that maybe. And I might ask, so an interesting analysis question that I might ask here is, what is the description of the item with the highest unit price? Or what is the unit price of the item with the highest quantity? So that's another question that I might ask the extract. So those are meaningful data, right? So if you want to figure out unit price is a very bad metric. So let's instead say what is the description maybe? That's a very bad metric to analyze. So this one, the last one, someone might use it to say, okay, what's our top selling item here? They might want to do that. So then what you would do is you would ask it to analyze, and yeah, then it would operate with S3, and okay, it's sent to analysis. So okay, that's the speeder. So that's where it polls now. It's polling it right now, and it's doing it until it gets a response, right? So you can determine the polling interval based on how you think or how quick you think it might process. So I have set it to poll for 2 seconds, which is not so good if you're running it on like mobile because that's network training. So yeah, so let's just wait until it analyzes it. But yeah, so let's see. Okay, so I think it popped to the front. So now, what is the unit price of the item with the highest quantity? Okay, it got that definitely wrong, but it's very confident about it, right? And then what is the description of the item with the highest unit price? So let's say highest unit price is 100 front and rear brake cables. Okay, it got that right. With the highest quantity, so I think it, oh no, what is unit price of the highest quantity? Is that 100? Okay, no, it got that wrong. It definitely got that wrong. So who is the shipper? We wanted that. So who is the shipper? John Smith. And who is the recipient? Again, John Smith, because generally I would assume that ship to means the recipient ultimately. So you didn't, like we didn't even train the model, right? We didn't even do anything. We just consumed it. But there are cases where it will bluff the response, and that's the fun thing with AI, you really can't trust it. So, but it's still 81% confident that it was right. So, always. So, key takeaway again, don't trust AI completely, but it can give you pretty good amount of accuracy as well. So, the code for this, right? So, that's what everyone's really interested on. So, let me just try to open up my VS Code here. So I'm not going to code it out. I'll just show you how it works. So this is my front end. Again, I don't think anyone is here to see my front end. So we'll jump to the back end. Yeah. So let me just cd out of it. Okay, cd API and open up code. So I've used Pulumi to manage my backend, but you all can use CDK and serverless framework, anything that you all want. So what I've done is, so I have an S3 bucket, right? That S3 bucket I've provisioned it, so I wanted to keep my cost low for it, so I didn't have a really good price class. It's just a very few zones here. So, and then what I did was, so that's just S3 bucket, right? I don't want to walk you through the entire code here, but then I hooked it up to CloudFront and I've set up a CDN here so that assets are delivered faster, right? And then I've also had a trigger or S3 triggers where once it determines that an image has been entered, right? So this is the callback that little function, or that is the event handler for an image that's being uploaded. So from here, it will get the image ID and it will immediately start the job ID, right? So now here we can see that we are passing in our queries and we are going to map it to a question. So that's essentially what we're passing in the queries, and we are going to use this client request token here. So this is what you use to implement something you call as message deduplication, right? So that's a very fancy term, but what it essentially means is you avoid processing the same thing for a certain number of attempts or certain period of time. You prevent it to process, because what's the point of processing the same document if it's being sent, right? So what I've done is I've given the DynamoDB entry key here so that if it determines that, okay, someone is trying to process it again, but it's still being processed, there's no point sending this to processing again. So that's another part where I did that. And then this is the part where we talk about our notification, right? So this is, if you go back to the diagram here, so if you go back to our diagram, so this is essentially, okay, this is essentially this part. So now it's pushing it onto SNS ROM. This is step number 4. What happened? This is, I don't have anything configured here, right? No code which says push it. It automatically does it. I just have to give it the topic name. With SNS you have topic, so I just give the topic name. And in my topic, I have a topic subscription again. So that's this topic subscription, handle text track response. And from here, I talk to text track and I get the document. So this is this step right here. This is from step number 6 to step number 7. That's this process. So this is the number of lines it takes to build this solution. It's actually close to nothing, right? It's just like 21 to 30. So like 9 lines to get a document, right? And then I update it on DynamoDB, saying the status is completed. So while this is initially put, it's gonna be processed as pending. And then once it's completed, so as you keep polling through it, it will check, okay, I give you the job ID, what's the status? If it's pending still. If it's pending, I'm gonna keep showing the spinner. If it's completed, I'm gonna directly fetch that item and I'm gonna show it in the client side. That's essentially what this code block does. So the code is also available. So yeah, I've also made the code available for you. So just scan this and the code is actually present on the second URL. So it will point to my GitHub and it's bit through ISG. So all you have to do is just run the deployment command and change the DNS name to your domain and it will just deploy it. It's like magic, right? So yeah, so that is my talk. And any questions, guys? So that's exactly what I wanted to present to you. Any questions?
Quick one. So I would like while I was listening to your talk, I realized that we upload sensitive documents to extract, and I wanted to see where what Amazon or AWS does with the results. Does it train its model again using that, or what's the AWS implication?
That's a very good question. So I actually did my research on this. So the fun part is TextRack doesn't use its data that you give to retrain the model, right? These are all trained models, and it uses over millions of data that's been pre-trained. So it doesn't keep retraining this model, but if it does retrain, there's a strict policy which says it does not take your data, it discards it, because TextRack doesn't have permission from the, when you give it an IAM restriction, TextRack doesn't have permissions to fetch documents from your bucket. So that's you define through TextRack. So even an S3 bucket, if AWS was using it, so AWS would need access or a permission to access resources in your bucket. So you can define that through a policy again. But again, TextRack does say that they don't use our data to train the model, because sometimes when you do use customer data, your model tends to get bad, right? That's what happened with GPT. They tried to train it on customer use data and their entire model got dumped actually. It was very bad at logical reasoning. So sometimes it works out well using data, but AWS doesn't use it. So that's something that they have defined on their policy again. That's one question. And when you are trying this, guys, don't upload anything like sensitive, because it is a public bucket, so anyone can see through the app. So yeah, so it is not private, so it is a public bucket again. So I should say that. So it is read public reads. So 4 days. TextRack will automatically clear its data based on after 4 days. Do we have another question?
Yes, my question is like, questions we asked, it was wrong.
Yeah.
So is there any way that we can combine it with, let's say I'm using this specific versus this use case or something. Can I define a formal structure and say I'm going to write queries in this message and then have the contextual abstraction and problem that we use?
So to answer your question, TextRack only supports English at the moment, but there is another service called Amazon Comprehend. So what that will do is, so what I did is I directly gave TextRack the query, right? So instead what I can do is I can couple the two services together and say, once you finish analyzing, send it to Comprehend. So Comprehend will try, it's another model that's based on further analyzing natural language. So that is better than TextRack actually. That is better at providing answer to these queries. That will definitely solve this problem if you couple it directly through Amazon Comprehend. Yeah, but to the direct answer to the question is no, TextRack does only supports English at the moment. Yeah. Any other question?
I have a question. Okay, I'm not being into AWS. Since you have like multiple service like AWS, Meetup, and Meetup, so is there a way that we can like combine these like as you show the slides with the GUI, we could do the stuff like
Yes.
and then we would call the code maybe APIs using VS Code maybe.
Yeah, I'll show that. Yeah, I'll have to show that. So if you are new to AWS, try browsing this service. So it's called Application Composer, right? It's literally what you told, building blocks. You drag and drop it and it generates the code for you, right? So I'll just create a quick project here. But one caveat here is it doesn't support every service, right? So it supports these services at the moment, right? So okay, it has added a lot of new support, which I did not know. So if you want an API gateway, you drag it here. You want a Lambda to talk to it, have a Lambda function. And now it's a standalone Lambda function still, right? Then what you do is, you take this and you drag it. And now you have the connection. So that's a get endpoint. So now what I can do is, let's say I want to change this to hello here. And now when you go to /hello, this Lambda function will be invoked. And then you can also edit this Lambda function and say, okay, these are the memory configuration, timeout, provision concurrency, IAM permissions, environment variables. And let's say you want it to talk to DynamoDB table. There you go. You just drag this and say, okay, Lambda, I want you to essentially have a connection to this table, right? So now what it'll do is, you see it automatically added the CRUD permission to the table. So it automatically managed the IAM for you and it gave you this table name. So in your code, you just refer to that environment variable. And then you can define your database schema through this. And let's say, again, you want to do asynchronous processing. Hook it up like this, right? And you want a queue, maybe SQS, you directly integrate it onto this, right? So, okay. So, okay, connection from table to queue not yet supported, right? So, they are still, so this will release last November actually, right? So, it doesn't do everything, but to get started with an API, so I actually tested this out. It took me like 9 to 10 minutes to build a full API with CRUD operations, right?
So I asked because I've been trying to do connect to service using that idea.
Use this. Use that, yeah. Application Composer. Yeah. Yes.
This is very fascinating. It's one of the last custom ones, sorry. Custom nodes.
Purely what AWS provides, but you can, so there's another thing called if you go to template, right? So this is essentially through CloudFormation. So if you can write a CloudFormation script here, it will show up as an unsupported entity here. So technically, even if the table is not supported, you could create Yeah, you can. You definitely can. So what I can do is, so let's say I can have a lambda function here, and that lambda function would go to this Dynamo DB stream, and from here it would have a subscriptor to the queue, right? But then again, you're adding latency to your requests by doing so, because lambda will go on the cold start. So directly you can couple that to SQS, but then again you have payload restrictions there as well to a certain extent. But yeah, you have the capability to do that. So here you can say if you want to add a DL queue, so dead letter, right? So you add another queue which acts as a dead letter. So now what it will do is it will hook it up to a dead letter. So dead letters are essentially if the queue fails the message, so if the consumer fails processing it, you can say after X number of attempts, push it onto this queue to store the error entry. So then you can inspect it, and if you fix the error, you can start read write, and it will push it to its original source again. So that's essentially that. Yeah. Any other questions, guys? Yeah.
In terms of customers, so when it comes to this coding,
We can double check on the pricing actually. So I don't want to give you a false number, but let's head over to the pricing page. So queries are essentially for the first million pages you analyze, you pay $15, and then for the every million after that you pay $10. So generally queries, it's like this, right? You don't pay for the analysis of the document. You pay for what you request from it. So even if it's 100 queries, you don't get charged for the 100 queries. Again, so vector extraction, again, textract does give you the actual X and Y coordinates of every raw text that it finds. So it gives you the X and Y point, and you're supposed to handle that on your own. But consider, okay, in terms of accuracy, you might have a better approach with vectorization again, but the effort it takes to build that logic. If you want something that runs tomorrow or next week, it's generally hard to have a traditional place where you process it and then you map every vector, right? Because you have an infinite possible combinations for the document. So for one document, you might have your vector as your sender as on the left. For certain format, it might be on the right. Then you have to map two vectors there. So then, based on the cost to benefit ratio, if you take a look at that, textract wins there. But you can use comprehend actually. Comprehend is a way better service in handling queries here. So that's, again, it's a bit more pricey. Yes. Any other question, guys? Yeah.
based on the query that I'm asking, markup is say there is some markup that I can define. I want you to convert every video you can convert this single markup format. Can you use every kind of
you have to integrate it onto your code base, but extract does do this to a certain extent, right? So it's not just queries. So with extract, you get all of these. So you get the huge chunk of raw text, and then you get your layout-based data, right? So it determines on this layout what's the data it defined on the header. So it's able to segregate data as well, but to implement your logic, you would need to handle that through a different code. There is no tool that can actually do that. But textract on its own would be accurate enough to do that because it has been trained on millions of POs. So it's training. If you take a look at textract's training set, so textract queries were again trained on these documents, right? So it has been trained on bank statements, pay stubs, loan, notes, mortgage notes, all of these documents, it's pretty able to identify it. So what I would recommend is you could try it out and see if it gets the job done. But there is always a chance that AI is not 100% accurate. Even it might give you 99% accuracy, but it will bluff. So there's always some sort of sanitization that's supposed to be handled from our end as well, right? So try comprehend. So comprehend is a better approach for this. Any other questions, guys? Any other question? All good? Okay. So if it's all good, we can move on to the next phase. So don't worry, I'm done. I'm not gonna be talking to you much more longer. So I'm just gonna drop the slide and hand over the presentation. So yeah, let's just go on to the last part. Okay, this part. Right. So this is the quiz, guys. So I'll be handing it over to Lahir, who's gonna be talking to you about the quiz and the gold prize that you'll get. So over to you, Lahir, and thank you, guys.
Thank you, Lucky. Can we have a round of applause, please? Thank you. How amazing was that? Nice. So, like I said, it's time for our quiz. I hope everyone is listening. I heard a bunch of, bunch of questions. So that's good. You were listening. You were awake. Luckily, they didn't put anyone to sleep. Hopefully. All right. So I'll give you a couple of minutes until everyone scans their QR codes and gets in. But hold on a minute. Okay. Give me the other laptop. Give me the other laptop.
Meet Harish, a software engineer here at Causant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Causant's flexible working culture. Explore Causant's flexible benefits.
All right, so the QR code is there. Sorry about that, guys. I can. Okay. We'll wait a couple of minutes because we only have 11 participants at the moment, or 12. And if you have anyone who's joining in on the live sessions and all, you can use the link. Yeah. So while we are waiting for the quiz to get started, Has everyone posted their LinkedIn posts, tweets? So just a heads up, we're going to give a T-shirt as our, prize for the yes. If anyone has problems logging in, use the QR code or the URL. So 30 participants so far. How many did we have today? So we have 6. Yeah, we have more than that. So if you use the code, it might say it's expired. Probably in the platform. You scan the QR or like everyone okay, or are we having any difficulties to? Could you use the URL, please? On the bottom. Does it say is expired? Anyone with any issues or problems? Or we log in? 37. Can I raise a hand to see here? Yeah. So I'm 42. Can we start or are we still waiting? Sorry. Anyone else having technical difficulties joining in? Anyone raise hands? Excited? Could you try the URL, please? So all the QR codes. Anyone else? Or is it okay? All right. Did we get it? Oh, we have that. No? QR code and the URL? One of those not good. No? Okay. Could we try it rather than signing up using the URL here? Don't use this one. Use. Anyone else with problems? Well, trying to connect on the problem. Anything? All right. I'm very sorry. We'll start in the interest of time. Yeah. All right. So, guys, listen up. We're gonna start. You're gonna have 15 seconds to answer the question, answer it correctly, and take as less time as you can. Right. The fastest correct answer wins. All right. So we have 10 questions. I think 10 questions. 10 questions. All right. So we have 10 questions. So all the best. So we begin in 5. What does it mean to build with machine learning for 2024? So we have 10 seconds to answer. I see that everyone's answering. All right. Focus. Okay. So most of us got it correct. Obviously, half of us. But it is to use inferencing, right? So you don't really have to train models. You don't really have to, basically put in the effort. You just ask the model questions. All right? All right, and this is the leaderboard, by the way. So, all right, so everyone got the hang of it, right? Don't skip any questions, right? Guys, don't skip all this answer, right? If you don't get a chance to come back and answer. All right? Moving on to the next question. What is an example of a computer vision service in AWS? AWS, Amazon Tech Stack, Amazon Comprehensive Recognition, or A2I. Okay. So let's see. All right, it's Amazon Recognition, right? Again, guys, don't try to skip. Try to answer with something that you know, or just. All right, so let's move on to the third question. Unpack them. Just see what are text stack queries trained on? Family pictures, human voice, vaccine card, animal pictures. We spoke about this during our Q&A, right? Like we mentioned a bunch of things that it's trained on. I'm excited to see the answer to this. Majority of it, out of the answers, it's vaccine cards, right? It's not trained on animal pictures or human voice. It's text stack, right? Text, not voice. Okay, so that's the gist of it. All right, so we have a leader after 3 questions. So we have Deshan J. Deshan, oh nice. So we'll see if he stands to be the leader of the next question. Okay. So our next question is, what is a text stack query? All right, so we have 3 answers. Is it a way of getting answers to data in a textual document? Right? I don't think I have time to read it. So we'll see who gets it correct. So mostly everyone got it right. It's a way of getting answers to data present in a textual document. That's what we've spoken about in the entire session. Right? All right, so we're going to move on. Guys, don't skip, right? What is serverless computing? I think this is a question that we talk about every session, right, that we've done so far. So, see who gets it correct. All right, so this is okay. Let's recap and explain, right? So it's okay. Serverless does let you run a service, right? But you don't really necessarily have to keep it up and running. The answer is a bit confusing, right? So basically, what you can compare is with the EC2 and a Lambda, right? Like I said, like Laxmi said, right? Idle time versus not paying for idle time. So that's the basic gist of it, right? The answer is pretty confusing. I understand that. So that's up to you to decide. All right. So why do serverless applications blend well with machine learning? All right. So the very ML workload event-driven architecture helps out with Expose API and performs very. Okay, so this is where things get interesting. Say, like, I think most of us got it correct. If you guys have any questions regarding the or clarification regarding the question, just please raise your hand and then we can go through that. Right? If you have any issues of why you got it wrong, and this is about sharing knowledge and all that, right? Okay. What's the role of SQS with extract? I think alright, so here's the thing, right? So this was in his architecture document. It doesn't really have a so it's in his document, right? That's what alright. Nice, right? I think everyone got it. It's to avoid exceeding the rate limits of extract. Right?
So number 2 is also correct, guys, because I did speak about the deadline queue there and I was explaining it. But the actual answer looking for is the best one because I made it using for a broken code.
Yeah. All right. So sadly, we can't really go back and yeah. Sorry. You're gonna argue with him. This is the first time that I'm seeing the questions now. For everyone who answered the second question, very sorry. On behalf of Latin. Alright, so what is the event used when an object is inserted on S3? I'm sure he put it in an architecture document or somewhere. Let's see if you got it correct. Okay. Yeah. So it's actually object created because you create a document, right? And you don't put it. Lucky, do you want to give a explanation to that?
So the event that AWS S3 emits is so yeah, so the event that it actually emits is object created, not object put. So I actually didn't cover this while I was explaining it, but it was there on the slide. If you look at my arrow there was a huge hint, it says object created. But yeah, that one's just something to guess here. So yeah, I'll just leave the mic because
I have a lot of enemies. No, give the mic a bit. I think we have a lot of questions after this. All right, so that was in one of his arguments. Right? So we'll move on to the next question. So this is the 9th question, right? So we have Athavan in the lead. I'm sorry?
Someone, you won plenty of quizzes before, right?
I know, refreshed. It'll get you back into the.
What is polling? The client invokes the API at a fixed time period, requesting for a response from the server. Thank you.
Okay. So, I think everyone got it correct one? Everyone went down?
Sorry.
Oh, okay.
That's the fun part. You just start bluffing at like the 9th, 10th question, you start bluffing, is it or is it not? Yeah.
Alright, so okay. That's one way to put it. Okay, so we have the last question going on, okay? So we have Athavan in the lead. Rithan catching up, right? Alright, so last question to win t-shirt. Alright, we'll see what the question is. What is the role of SNS? I think this is pretty basic. This doesn't really have anything to do with machine learning. I think like the lot we ran out of questions for machine learning. Yes, that's what I thought. Yes. So what we will see is it is a distributed messaging service, right? It doesn't process anything, it just takes it and dumps it out. Right? And it's not a queuing service because it's SQS, not SNS, right? Alright, so who is our winner? Okay. Okay, okay. So we've also has a winner today. So can we have you up here to give a token of appreciation, and what size of t-shirt do you wear? Large? Large? All right, here you go.
So where are we gonna? I think we could give it that frame as well. Yeah.
Can you come here? Your face is the
You want me to
reflections are taken.
okay. I started this last time and I'm going to do this again. I'm going to take a okay. Yes.
That was unexpected. Thank you, Coden, for that. All right, so shall we move on to our next segment? And for everyone who timed out, I'm very sorry. Very sorry. Yeah. We'll do it after. So, guys, the giveaway winner will be announced after the breakout session, right? So, can I invite Keshav to start our next session? Right, can we have a round of applause, please?
Okay. Yes, hi. All right. First, I'll just.
Yes.
Oh, bye.
We didn't have pencils. No? That's a bit. I already break into like groups of 4-5 people. I'll just hand out these events and you want to do.
Yeah, so what we're going to do is, guys, so I've come up with a small scenario that we can go through together. So that's it's there in the full paper that Lakin was handing out. So what we're going to try to do today is to kind of build a solution for this problem. I made the problem, I didn't make it very complex, nor did I make it very easy. So there are certain things you can think of it and do, but overall, it's kind of the architecture. Once I show it to you later on, it might make sense. I mean, it might be simple, but we can obviously debate that. It's not one correct answer in it. So I want everyone to kind of get involved and discuss and see what is the correct solution. Yeah. Yeah, sure. Yeah, of course. I thought I'd first go through the scenario and then I'll use this.
So, anyone else? Yeah.
Okay, I think everyone has a sheet, right? So what I'll do is I'll just first go through the scenario and then we can just discuss on how we can develop like architecture solution for this. So what I thought for this session is, now this is a very common use case when it comes to AWS and cloud, and this is what usually people try to do with AWS. It's where these big businesses, they try to migrate their on-premise servers into AWS, and different businesses have their own, I would say, requirements. So these are some of the requirements I have designed for this particular scenario, but these are somewhat generic as well. Like mostly organizations nowadays, they will have some similar requirements when it comes to moving to cloud. So this shop here, I just named it Tech Shop. It's an e-commerce application, and right now they have on-premise services running. They have both their front end and back end, and they have done some sort of a basic networking setup in their on-premise server. But what they have felt is now that their business is growing and they are getting a lot of users, it's becoming harder and harder for them to maintain the servers, and they are looking to see if AWS is a good option to move to cloud. Right? So when they are moving to cloud, they have certain concerns out the back, because the way they have set it up right now, they want to make sure some of these points, I have mentioned around 8 points here. So they want to make sure these points are covered, at least in the beginning, when they move their application over to AWS. So the first thing I have mentioned here is that they are right now running microservices based off of Kubernetes. So I'm not sure if everyone here, hands up if everyone knows about Kubernetes. There are some who have known. But so for those who don't know, Kubernetes is a orchestration service. So we use that to orchestrate different containers. Now, if you have worked with Docker containers also, you might have a bit of an idea of, or you might have heard of Kubernetes. But it's a good framework to create microservices. And they also have a React application that's their front end, and that's currently both of them are running in their on-premise server, and they want to move that to cloud. That's the first thing where they want to do. So they want to move their backend as well as their front end to cloud, right? Then they want to make sure that the network of the application is secure. That means whatever resources, both the backend and front end that they're going to host, it has to be completely isolated. There shouldn't be any direct access to these resources, because there might be some sensitive information there. So yeah, we are going to access it through the internet, but there shouldn't be any direct access to the database or open access to the database. So that through the internet, you shouldn't be directly connecting to the database. Through the application, yeah, the application will expose only the required services, only the required endpoints. So that is fine, but they shouldn't be able to directly access the code or directly access the database. So that's a network level security that they want to ensure in the application, and they need it. Next thing is, yeah, it's the main thing which I addressed before, is that they are getting a lot of users. So they want to make sure these Kubernetes clusters that they are running, it's running it's able to handle a lot of requests. It should be able to scale up and scale down and handle millions of users, preferably doing some sort of load balancing, and make sure that the server is up and running when the requests are being sent into the application, right? Also, they have my MS SQL database running right now in their server. They want to migrate that as well into cloud. So what can we do there in AWS? That's something you can think about. This is something something that these days a lot of the applications face is cyber attacks like DDoS. For those who don't know, DDoS means denial of service. So your application gets spammed a lot with a lot of network requests, or there's these kind of cross-site scripting, and there are a lot of these common vulnerabilities that we see these days increasing a lot because there's a lot of hackers out there just trying to mess with the application. So this product here also, they are also facing this issue, and they want at least a basic level of protection when it comes to these kind of cyber threats as well when they move to AWS cloud. Yeah, and one more point here, there's going to be users all over the globe for this application. That means no matter if you're logging in from Sri Lanka or America or Australia or wherever, they are expecting some sort of a similar performance. The performance shouldn't differ from the region you are in. Geographically, wherever you use the application, the performance has to be the same, especially the load times and the application responsiveness has to be the same. So how can we accommodate that in AWS as well? That is something we can think about. This thing I added it just as a kind of a thing. It's a very specific use case, but this is not generally the. I mean, it is used a lot in different enterprises, but I added it just to make things a bit interesting. So they also want to do this blue-green deployment when they are releasing their new when they have new updates for the application. So for those of you who don't know what blue-green deployment is, some of the bigger applications nowadays they do that. Facebook, Instagram, things like that. So what they do is they will create two different versions of the application. There'll be a blue version and a green version. Blue will be the new one. The green can be the already existing one. So what they do is when they release a new feature, they will slowly move some of the users to the blue environment first. See how that works out. If it works out fine, then they'll switch everyone to the blue environment and keep the green as a standby. So the next time what they'll do is they'll deploy the green, and then they'll switch from blue to green, and then see if green is if the users are okay in green, and then they'll switch it back to green. So they'll have these two environments running just so that they can seamlessly roll out their application, any new updates or any new features that they want to release. And here, TechShop also wants to ensure that through some sort of a continuous integration and continuous deployment, like that means through some sort of a pipeline, they want to make sure that these kind of blue-green deployments can be done as well. I just added it there just to give you guys an idea about blue-green and how we can do that in AWS. Finally, while performance or security is paramount, they also want to optimize the cost. So they want to see how the application performs once it's deployed and see where they can cut costs. Once it's running in the cloud, cost is one of the main things they want to see. So they just, while the application is running, how can they monitor the application and see whether they're actually efficiently using the resources in AWS and what kind of cost-cutting solutions that they can take or any kind of recommendations, best practices that they need to follow. So that also they want to know when they move to the cloud. So I know I covered, I had a lot of points here. So what you guys can do is just come up with an architecture. It doesn't, if you can cover all 8 points, that's really great. But at least the main points where you can move the microservices, create a secure network and make it available globally for the users, that itself would be great. The extra points I've added here is just to spice things up a little, because the architecture that I'm going to show, it's just one way to do it. There are multiple ways to do it, and we can obviously discuss that, because I have made some assumptions when I did the architecture, which I will explain. But like that, you guys can also have, so I have mentioned here, point out any assumptions that you make, because that's how things change when it goes to when you actually deploy applications in the cloud, because different scenarios and different enterprises will have its own requirements. So based on that, we'll have to kind of cater it according to that. So yeah, this is what I have come up with. There are certain small specificities there, but overall we can come up with an architecture. We can discuss it. So what I want to do is, like, you guys are in groups now, you can just discuss a bit, maybe draw a diagram, or just, if you can't draw, just at least for these points, what kind of service can you use in AWS, or how can you set it up? Something like that, that will be great. So we can discuss it quickly, and I'll also provide my input, and we can have a healthy discussion. So yeah, so I'll be moving on, and then Lakindu, Airu also there. Just can ask if there's any doubts. And you guys know this. So yeah, we'll make it interactive. If you have any questions, please ask me. We'll take about, let's say, 30 minutes or 20 minutes. 15 minutes.
Yeah.
Okay.
But how long? How big is the solution?
I know.
When you did it, how long did it take?
Okay, maybe
20 minutes? Yeah. Yeah, overtime? Okay. It'll take 20 minutes, guys. And then I'll take another 10 minutes after that just to go through my yeah?
And if you guys have any questions, like, you can raise your hand. We're there to help you out. Right?
Yeah. Oh yeah, so once you guys are done, I will ask, one of you guys might have to present it, so yeah, be ready.
Meet Harish, a software engineer here at Causant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Causant's flexible working culture. Explore Causant's flexible benefits.
That's a good solution. Yeah, it has geographical, multiple geographical You said this too, so I know. Yeah.
Meet Harish, a software engineer here at Causant. In Harish's world, work and life harmoniously coexist. Whether it's tackling coding challenges or taking care of important activities, he's got it all figured out with the use of Causant's flexible working culture. Explore Causant's flexible benefits.
How we can design a solution. So basically, wants to do it first. Any volunteers? Okay, yeah, you can talk. Or you can just say it. Yeah, just yeah, that's fine. I just say. Okay. Even easier if you use ROCD to switch to looping deployments, even with the Kubernetes tests. Yeah. Okay, great. Thank you. So, yeah. So if you guys caught what I'm saying, like he has gone for a EKS approach with RBS and then use CPC stuff. So that's a very good architecture. I show it kind of I have similar elements in my architecture as well. But yeah, but that kind of thing. Who else? Yeah. Yeah, you can just start. Talk with my
My architecture is a EKS-based application. Okay. So for the availability, in case you have this node, inside these nodes you can have pods as well. And to secure it inside the EKS cluster, you can have this public subnet and the private subnet. And my web application will be inside the public subnet, and the application and the database will be inside the private subnet. So for the data migration part, we'll be using the AWS tool to send all the data from MS even to RDS. And RDS will also be inside the private subnet of the EKS cluster, and the EKS cluster will be inside the VP as well. Then, for DNS resolution, we'll be going through the route 53 and it will go to the cloud front, so that it will be cached inside the cloud front as well of the request. And inside the VPC, I will add the internet gateway, so the nodes inside the public subnet can communicate with the gateway as well. We're going to that have placed an ALB references with for the CI/CD pipeline is going through the whole pipeline, and all the images will be stored in Kubernetes. The layers will be up from the CI. And for the authentication, can go
yeah, that's great. That's a good answer. Yeah. So he also considered authentication sitting next to it as a good option. And he also mentioned that you can use the ECR to store the containers that you're going to use to deploy weekly. So that's also a good additional idea. Those are things that you mentioned, so that's a good catch. Yeah. Anyone responsible? I think you guys might have already what some of the things common like EKS and maybe VPC, because I guess those things are pretty straightforward, so it's easy to do. But some of the things like the program deployment is kind of for discussion, because you can do that in different ways. Where you know, yeah.
I'm just going to do one of the things that you guys missed. Number solution is by EKS. It's already on-prem so and CloudFront with an S3, because it's in the application, we can build it and put it in S3, and CloudFront will be this again. DB will be migrated from DNS to the RDS. Database will be file subnet. EKS will be on target for host efficiency, and it's also will be what's called VPC, and it's also we can put it in the file subnet. I think that's alright. For the default that's another was we can have Shield, but it's expensive. But CloudFront we have the Shield standard. And we can have that. We can have with Meetup, providing free
role sets, behaviors, pretty and we are not exactly have much idea about local deployment, so we are passing on it. And of course, during the questions, we will have trusted deadlines as optimized Okay, great. So you consider the costing to be some of the experience, so that's a good point. Thank you. Okay, you want to discuss something? Yeah. We have UKS, so the application load balances and load distribution. And then it's a weekend actually, it's a really good diagram. Yeah, so then we have SNS and SQS student and okay. Yeah, okay. Fine? Yeah. What's the name? Leadership. So, yeah. What he was explaining was the market in two VPCs in two different regions, and through VPC PI, we have connected both the VPCs. Yeah, continue. Then we have EKS for the trainers in private sector, so therefore we can make the direct private subnet. We have SPS for the microservice applications, and then we have RTS, so we have this we already have so the CC2 might use that, and then we synchronize the availability costs, and then we have enabled some of the private resources for the developers and login via STL nodes, so we have we have OCD, one of the open source traits for the CDCD, and then we have Outfront, and we have Route 50 for the extra security purpose. It's about verification, so we can't do any IP testing or anything like that. Since we have the network tool already configured and we have multiple subnets, so we can avoid the slow side attacks most of the time. With client side, okay. Yeah, that's it. So when you come down to the project, someone is actually not a proper diagram to really that's it's actually what what I'm going to show. So this is really next time. So I think the same kind of participation that we are. Yeah, you can. Okay, you can also anything that I think we covered a lot of the cases, but there are still certain things that they can do differently. Anyone has any blueprint how we can do the blueprint deployment? Any service that in not perfect? Okay. Anyone else like to proceed? So I think maybe in the interest of time I can just quickly show my architecture if anyone is okay.
kind of feedback. So, so I'll quickly run through the picture I did. Again, this is after debate and also somewhat similar to this. So, first thing is application cloud, right? So, the service that you use for that is EKS, and I think that everyone can that's the obvious solution. But EKS, you can actually EC2 with EKS. I chose EC2 here simply because I said overtime. That means that they can directly use the nodes that they have and put it into EC2. Target means we have to go with more configuration, but that's still a very valid option. It again depends on how fast they want to take it to market and what are they willing to do a bit more configuration or if they just want to lift and shift it directly. So that's up to debate. So I went for EC2 with auto scaling group so that when there's a high load, it will automatically scale up. You can horizontally as well as vertically scale that you can do. Yeah, so that's the first thing for the Kubernetes application we are using here. And for the second point of React application, I went for a simple S3 bucket with CloudFront, but I think this was also used in all the S3 bucket we can do store static content and we can use CD on front of it so that it will cache the content into the static content all over the world and geographically it is going to get the same performance when it comes to the application. But I have an interesting argument that I can't just store the content like on let's say EC2 instances. That's still a very good point. Why I went for S3 is just so that I don't it just felt like we can just again trying to what I consider that is you can really extract and directly put it into S3 rather than setting up your server. But it depends. So scenario he presented, he told like why he likes to manage the content as well. Maybe he wants to do some custom properties and things like that. When those you could do like EC2 as well. I think S3 approach is to make the time to market quite fast. So yeah. Then network security is again something everyone I think came up with. It's the VPC. So for those of you who don't know, VPC it's called the virtual private cloud. You have your own isolated network inside the public AWS cloud. So through VPC, we have our own isolated network, and inside that we have this thing called subnets. So what subnets is virtual isolations within the VPCs, so that you can place different resources into it. So we have public subnets and private subnets. How they define these subnets is simply where you place the NAT gateway, how the internet gateway is placed, and through the route table you can configure which one is the public one and which one is the private. So here I have two subnets running through the NAT gateways, and yeah, so I'm using that the subnets here to isolate my resources in the private subnet, especially my application network and my database is going to be running in two different private subnets. And through the public subnet, some of the I want to mention it here, but you could actually so through that you can, if you want to, you can connect to the database. If not, there will be direct access to the application server because of the subnet. So this is, I think already had an idea about this, but if you don't know, just Google a bit on how VPC and subnets work. This is not something AWS specifically of this concept. This is a networking concept. And even in other clouds, cloud providers, you could find similar, you can do similar architecture there. I kept it generic so you can move it around with different cloud providers. Yeah, so for scalability, I have done and availability, I have done a few things here. One thing is that the application load. Some might you can use as well. Why application is just
I like the fact that you can do proxy, you can do different route-based proxy, which is not bad, and network load balancer, and network load can be a bit more expensive in certain, if there's a lot of traffic coming through. So that's why for application. But again, network load balancer is also a good option if you want to, performance to be there. So I use application load balancer and auto scale group, so both of them will be useful for scalability. And for availability, now I have moved it to two different zones. So I think Lucky also made a huge presentation about availability zones. So it just means that within the same region, you can have there are different data centers. But one of the data zones down, it will automatically fall back next availability. So when you feed resources across different availability zones, the availability goes down, it will automatically go from another region, another availability zone. This can further improve. So that's what that I just wanted to show it, but you can see he showed it itself. So you could further improve this by having this VPC in a different region as well. But there's cost is a concern, right? Because you're going to have the same application, this box in a different region as well. So if this entire, let's say I'm having this in the AP of the Mumbai region, and Mumbai region entirely goes down, if it still has running in a different region, let's say Singapore, so it will automatically, you have rules to pay off to Singapore as well. So that's also valid option. I didn't want to get a bit complex, so I'm just going to get one region perspective. But that's it. So the lot was that websites like Amazon and Best Buy, they have regional Amazon.com and Amazon.co. Like that, each region. So some of these websites, what they do is they have different deployed region as well. So in case they can switch over, and also they can doing isolation, right? So if the data is close to you, so close to you, so you can get quite fast. That's another option we can consider when we are talking about availability and scale. And for the database, I just mentioned RDs here. Again, it can be available. You can use as well, but again, so to make things faster to market, I use RDS, but I added primary instance and secondary standby instance in different subnets as well. So first price is available, but I went for I want the availability of price. So if it's the primary going down, the secondary standby we can pick things up. Just for the availability, I added another node, but that's up to that's again debatable, and it's a trade-off that we have seen when we are designing, right? So next, for cyber, that's what I'm beginning with. Again, I'm using for DNS mapping, so we can route all the users to correct application. But the main thing I really was now what is good starting point. What I mentioned in the service was I just wanted a basic starting point to at least a network level protection, so that there won't be any kind of these kind of process scripting or data attacks. So the starter work is good, but if you are serious about Shield is really good. AWS Shield is a really good service, but again, that cost involved there's a trade-off. So Shield is a bit too. That depends. So when you move to cloud, you feel like you really need you feel like a lot of people are need a CEO, you need more protection, then Shield is good because you are going to you're earning more, you're saving more money than what you're spending on Shield because it's keeping application protected. So that's another concern, but for simplicity's sake, I just added block. And I'm also using ACM so we can rotate our SSL certificates for the We can either use the ACM provided one, or you can import your own custom certificates as well. So that's a small addition I added, yeah. And to make it geographically have the same performance, that's why I added cloud EDU. So it's a content delivery network. I think it's caching your application, especially how you want. That you will cache your application state across the region. But that is so this couple of things where if you just use CloudFront, you always have they always have only information, but CloudFront is replicating across different countries. But in case of more availability and you want to make sure all your users have the same, you want to keep the data as close as possible. If you can do anything like you can say here is GDP. It's a European Union that to keep the data inside the European Union. So in situations like that, we can't always just stick to one. Store the data in according to compliances and regulations. That's one thing I didn't like here. It's just that when you consider these compliances, then certain things none of here has to be changed. You keep it in the correct region, and then you can have payload between different regions as well. So that's another thing you can think about. Yeah. So the last two things are the blueprint funds. That's just a fun factor that I added. So there are multiple ways to do blueprints, but I have for here is if you are using services, we can use let's see continuous integration and continuous development as well. So you can use all these services: code pipeline, code deploy, code build, code commit, and ECR. ECR is what that is mentioned. So ECR is there you can store your container. Since this is a Kubernetes application, there will be container. So there will be you can store the container repositories in the container inside ECR and use that to deploy application. So there's a service called code deploy is really good when it comes to these kinds of deployment strategies. It's not just globally, you can do other deployments like Lineage and there are couple more. So you can search a bit about code deploy and how that works. That is a really good tool when it comes to doing these kind of blueprint deployments. But that's not so easy because Kubernetes itself has its own solution when it comes to blueprint itself, because it's already running in a pod-based architecture. So you could, within Kubernetes itself, set up different pods so that you can do the blueprint deployment within CK itself. But if you want to upload that complexity, then you can from code deploy and scripting. So that's one thing I said. And finally, for the cost efficiency, just to monitor and to see how we can improve the cost over time, I have used AWS budgets, cost explorer, and trusted advisor. So trusted advisor will scan all the resources and it will provide recommendation on where you can cut costs, what kind of best practices you can follow when it comes to AWS and how we can save costs when it comes to security. And this is CloudWatch you can use. So you can send your application what to CloudWatch. And from CloudWatch you can do different complex things like you can have metrics and watch analysis. There are certain metrics you can set up so that when there's too many requests coming in or too many application failures in particular service, then you can notify or you can see how it's affecting your resources and things like that. So you can set up different workflows. But these services together will be really helpful when it comes to managing costs and see how well your application is performing over time. And based on that, you can take decisions to kind of improve your architecture and cost-wise a bit more. So yeah, that's the overall architecture I wanted to show here. Now, as I told, there are a lot of things here that can change based on the different
assumptions you make or how the customer wants to actually bring it to the cloud. But I want to leave here. What the thought I want to leave here today is just that when we are doing these kind of architectures, I have only mentioned like 8 points here, but there'll be a lot of different points that we have to consider, like compliance, security, performance, things like that. So first thing we'll have to do is when we take these kind of problems, we first see what are the requirements, and then based on that only we have to do the decisions. Some of the decisions will work out immediately. Some of them are obvious, like these VPC that I mentioned here, but some of the other things are kind of debatable. And it also depends on how much you want to, how much costs that you can incur and how efficient you want the product to be. So when you have these kind of, when you're designing these kind of architectures, what you can do is there's a website called AWS. I cannot read it. If you just Google reference architectures in AWS, that's a website full of different reference architectures. This is a very basic one, but they have a lot of complex scenarios as well. For example, if you want to do an airplane flight management application, then how would you do that? Like if there's different IoT sensors, IoT devices in your application, how can you design that in cloud? So do go and check that website out. That has a lot of different architectures that you can follow, and that will help you kind of think in different ways on how you can design the architecture. Yeah. So thank you so much, guys. That's what I wanted to leave here today. I think I took too much time, but yeah, we'll wrap things up, and yeah, hope you guys learned something new today. Yeah. Thank you.
Thank you. So, quick thing. We have a LinkedIn giveaway that's going on. So we have one winner who is answering is Don. Is it also? So we want one. From the answer, what size of t-shirt do you wear? What size of t-shirt do you wear? Medium? Awesome. And we have a round of applause, please. Thank you. All right, guys. Thank you very much for coming today. Can we have? Okay, we can skip the feedback today. However, thank you very much for coming. If you have any concerns or want to reach out to us. So you can reach out to us. We have LinkedIn, Instagram, Facebook, whatever, right? And I would like to thank Cosette for hosting us here, right, for the past 3-4 hours, right? So thank you very much, Cosette, for hosting us and for all the goodies that we got, right? Can we have a round of applause for Cosette, please? Thank you. Thank you very much for taking that and taking up time out of your busy schedule. Thank you, guys.
Before we sign off, we have a small token of appreciation to the WCC group guys for putting this together. We just posted it and just gave the video. So, Azriya. All right, thank you.
Thank you very much, guys. Thank you very much, guys. I hope to see you guys again for next meetup happening in October. Thank you, guys. And have a good night.